Yes, it's all good?
Yeah, all good.
Okay. Okay, so good evening to everyone. Thank you very much for attending today's seminar organized by the AIAA Sydney section. So my name's Julie. I am the WoMars Crew Commander and Geologist. So WoMars, as Nimish said, is an all-female crew composed of 6 postgraduate students and young professionals in space sciences. Back in October 2019, we applied to the Mars Society program to partake in a 2-week analog mission at the Mars Desert Research Station in Utah. We competed against other crews, and in early January 2020, we got selected to be the 241st MDRS crew and the 4th all-female crew. So our mission is scheduled for February 2021. And during our time at the analog station, each crew member will conduct scientific experiments related to their field of expertise. And as an all-female crew, we'll take this opportunity to evaluate the social and medical performances of women in isolated conditions. This will allow us to explore the role of gender in space exploration. The mission is a great opportunity for us to contribute to the research in space exploration by not only collect data, but also hopefully publish our findings. Again, as an all-female crew, we aspire to fill in the gender gap in space sciences and technology, and as well as to inspire other women to pursue STEM careers. For all of us, this mission is a first experience in analog missions that we all wish to reiterate in the future. And finally, it is a fantastic opportunity for us to conduct independent research and surveys. So the MDRS station is a campus with 6 different facilities. The main hub, let me grab the, if I can grab the pointer laser, yeah. The main hub is the habitat module where we'll spend most of our days eating, sleeping, planning our extravehicular activities. There also are 2 observatories. So a first one is remotely controlled, robotic solar observatories with the telescopes pointing at the sun. And then the second one, the MUST observatory, is a more standard telescopes. There also is a green hub. It is where we'll grow crops. It is a standard hydroponic greenhouse, and this is where Paula, our crew biologist, will spend most of her time. The science dome here is where we'll conduct most of the other scientific experiments, especially for Kelly and I. It is equipped with basic geological and biological instruments, such as transmitted light microscopes and incubators. And finally, the BRAM is the repair and maintenance module. It is basically the engineering research module. It is equipped with a rover, and this is where our engineers, Lorraine and Marta, will spend their time. So as you know, we are a crew of 6 female scientists and engineers. I am the crew commander and geologist. I'm from Switzerland. Christina, our crew executive officer, is from Spain. Lorraine, our crew engineer, is from France. Paula, also from Spain, is our crew biologist. And our 3rd Spanish crew member, Marta, is the crew scientist and media officer. And finally, Kelly, our crew geophysicist, is from Australia. So our group experiment as an all-female crew is to monitor our mental health in isolated and confined conditions. Then each one of us will carry individual projects according to our field of expertise. So Marta will focus on manufacturing and materials in Mars-like conditions. Lorraine will explore different Mars transportation systems. Christina will assess the potential of artificial reality for astronauts training in space. Kelly's research will focus on explorational geophysics. And finally, my research will be focusing on geology and astrobiology. So today we'll focus on Lorenz, Kelly's, and my projects. So in transportation systems, geophysics, and geology. But first we'll give you a brief overview of the 3 other projects, starting with the mental health study.
So the psychological study that we're going to take part of on our trip to Utah is in collaboration with the University of Iowa. The goal is to study emotional management in small groups in isolated, confined environments. So to do this, we will keep daily journals with predetermined questions. We'll also be documenting everything. And afterwards, we will be in debriefing interviews after the mission to reflect our emotions during the task.
Lauren, we can't hear you.
Sorry, my bad. So, to give you a quick presentation, our crew scientist, Marta, is pursuing a PhD in manufacturing engineering at Cranfield University. Her project will be divided in 3 sections: EVA suits, astronauts' diets, and drones. Now, Martian EVA suits are exposed to the harsh Mars conditions, radiation, extreme temperature, and the need to allow high mobility and supply oxygen. So Marta will be working on the materials used for these suits. In terms of nutrition, Marta will develop the diet we will be following for the 2 weeks, ensuring it is up to Martian standards. And finally, the drones project will be led in parallel with our partner, Spanish startup Dronomy. It will concentrate on navigation systems, since, as you know, GPS is not an option on Mars.
Finally, Christina's project will be focusing on artificial reality, so AR technologies in space. So Christina has a background in aerospace materials, and she's been working on developing augmented reality tools for repair procedures in aircrafts. During her time at the station, her goal is to evaluate how AR technologies could assist astronauts in executing daily tasks and activities. So to do so, using video recordings of our daily activities, she will classify each activity according to 3 criteria, so, which are difficulty, frequency, and the potential benefits that AR could provide astronauts. Christina plans to carry her project further during future missions by developing AR applications for at least 1 identified task and test the performances of these applications. So that was a brief overview of the first 3 projects, and for the rest of the talk, we'll present our individual projects in more details, starting with mine in geology and astrobiology. So being a crew geologist, I have a bachelor's degree in geology from the University of Lausanne in Switzerland, and I just recently completed my Master's of Research degree in geochemistry at Macquarie University here in Sydney. So the MDRS is an analog research facility, not only because it is an isolated and confined environment, but also because the campus is surrounded by an actual geologic analog of the surface of Mars. So on the left side here is a map of the state of Utah. Hanksville here is the closest city from the MDRS campus, which is about 10 kilometers west of Hanksville. The state of Utah has a very arid climate and is for the most part desert-like. It is also very diverse in terms of geomorphology, where many different landforms occur, such as remnants of impact craters. There are also alien sand dunes. We can find lake deposits. There are also both active rivers and paleo channels. And we can also see pattern grounds typical of arid climates like desiccation patterns. So all these different landforms have also been observed on the surface of Mars. To give you just a few examples, here on the left side is an aerial photograph of the Little Sahara sand dunes in Utah. And on the right side is a photograph of dunes in the Hellespont region on Mars. deltas are also in common between Utah and Mars. So this is a still active delta, the Weber delta in Utah, and this is a paleo delta on the surface of Mars right here in the Holden Crater region. Similar desiccation patterns can also be observed in both environments. Both of them are relatively large scale patterns. Here are so desiccation patterns in Dove Creek sinks in Utah, and again, the counterpart on Mars in the Utopia Plains. Finally, in both environments, we may find what are called blueberry concretions. So they are millimeter to centimeter scale round features that are believed to be made of hematite, which is iron oxide, and their formation is quite enigmatic, and they can be explained by various straightforward geological processes, but they can also be explained by the intervention of biological processes, and therefore they would be key astrobiological targets. So here's a picture in Utah and on Mars. So Mars has very similar features with Utah, and this is why it's a great location for studying the geology and the astrobiology of Mars. And which leads me to the main question I'll try to answer during my time at the MDRS regarding the type of biosignature that may be found in analog environments. So biosignatures basically are traces of life that are preserved in the geologic record in rocks. They may be of different types, including biominerals, like hematite, like the blueberry concretions, or magnetite as well. They can be fossils, both macrofossils, like famous dinosaur fossils, but also microscale fossils. And they can also be chemical biosignatures, like complex organic compounds, such as the ones recently detected by the Curiosity rover, and any other chemical signature that may indicate biological processes, like the isotopic fractionation during photosynthesis. While biominerals and microfossils require fairly basic equipment like microscopes, chemical biosignatures typically require more complex instruments like mass spectrometers, which the MDRS is not equipped with. So during my time at the station, my plan is to collect samples of rocks or regolith, which is just soil, and try to identify as many biosignatures as possible. So on campus, I will mostly focus on biosignatures that are relatively easy to detect, like biominerals and microfossils. But I'm also currently looking for a PhD position, and I'm hoping to be able to incorporate this mission into my research and potentially perform further geochemical analysis on the samples I would have collected at the station. Another aspect of my research is to test various sampling patterns. The Mars Perseverance rover, so from the Mars 2020 mission that will launch later this month actually, is designed to collect about 35 to 40 samples of approximately 15 grams each. So 15 grams is a very small amount. For example, during my previous astrobiological research, I typically used about 60 to 70 grams of sample. And even with that much sample, detecting organic compounds was quite challenging. So I'd like to determine what sampling pattern will maximize my chances of detecting biosignatures. Should I collect fewer but bigger samples? So maybe cut the sample set in half, about 15 or 20 samples, but of but higher amounts? Or should I stick to the Perseverance sampling patterns and collect 30 to 40 samples, but of smaller material? So that's it for my project, and now Lorraine will continue with hers.
Yes, thank you, Julie. To present myself quickly, so as my title of career engineering tells, I got a background in aeronautical engineering, and recently I've completed a specialized master's in space transportation systems focused on launchers and re-entry vehicles. So my study will be the following. As you can imagine, landing on Mars is obviously a colossal achievement in itself. But once we have a settlement there, what are the best means to explore the red planets? The goal of the study is to analyze and compare the three main means of exploration for Mars: rovers, roving vehicles, and finally, drones. Now, the two first are established technologies. For rovers, they have helped us explore the surface of the Moon and the Mars, Curiosity while still, for example, roaming the red planet. As Julie mentioned previously, they can now extract geological samples and even perform a preliminary analysis on said samples. On the image you can see here, it gives you a good example of the evolution of NASA's rovers. To give you a scale understanding, the Sojourner is about the size of a microwave, while in comparison, Curiosity is about the size of a SUV. So you can see the development of the rovers over the years. Julie, could you please? Now, NASA currently has a monopoly on Mars rovers. As I said, Curiosity is still active, and there were previous successful missions, such as Opportunity, Spirit, and Sojourners. The European Space Agency, ESA, is currently testing its ExoMars rover on Martian analog fields in Turin, Italy, with a launch delayed to 2022. Now, July and August 2020 is a very interesting period for Mars rovers, because not only will the Perseverance rover will be launched with the Mars 2020 mission, China's Tianwen-1 mission will bring to Mars a set of an orbiter, a lander, and a rover. Now, this illustrates well the dominant role of rovers in space exploration and the interest in space exploration itself. Julie, could you please? Now, as for the roving vehicle, although it hasn't been used for nearly 50 years, they are quite well-developed technologies. Now, the last one was used in December 1972 by the Apollo 17 crew on the Moon, as illustrated in this picture of Eugene Cernan. Now, during this mission, it traveled nearly, the lunar roving vehicle traveled nearly 36 kilometers in just 12 days, which is consequent when you consider that Curiosity has traveled about 22 kilometers since 2012. This brings up an interesting point, which is even if the risks of human space explorations is way higher than robotic space exploration, it is also much more efficient in terms of ground surface explored. Next slide, please. Now, the final mean of transportation is possibly one of the most interesting for us. In the Mars 2020 NASA mission, NASA will not only launch the Perseverance rover, it will launch its first Martian helicopter, Ingenuity. Ingenuity will be paired up with the said rover, Perseverance. It will send the outputs of its research to Perseverance, and Perseverance will send those outputs, those information, to a NASA Mars orbiter, and then the Mars orbiter will send the information back to us. So this illustrates that you cannot simply have an engineer in NASA just with a joystick controlling the Ingenuity Martian helicopter. It's not possible. You've got too much of delays in communications. This implies a completely autonomous navigation systems. Now, other challenges of the Ingenuity rovers are the atmosphere on Mars. As you know, it's about 1% as thick as the ones on Earth. And another challenge is the extreme weather conditions. Mars is famous for its sandstorms. Now, the last thing you want to do is send your very expensive UAV within a sandstorm on Mars and lose it completely. So this is going to be one of the biggest challenge of the NASA Ingenuity drone. To give you a bit of scale, I was telling you earlier that the Curiosity rover is about size of an SUV. In comparison, the NASA helicopter is absolutely tiny. It's 2 kilograms. Obviously, you want to make the weight as light as possible, so the drag is as small as possible. The height is about 0.5 meter, and the span is about 1.2 meters, which is smaller than when you just spread your arms. It will be obviously completely solar powered. Now, this Ingenuity helicopter, introduces really the study of UAV unmanned aerial vehicles in the studies that I intend to lead at the Mars Research Station.
Thank you, Lauren.
Hello, my name is Kelly Vaughan Taylor and I am the crew geophysicist. I'll be conducting a range of geological and geophysical surveys for WoMars. So the first question to ask yourselves is, why would you put a geophysicist on Mars? Well, the main answer to that question is we're very good at finding things. If humans were to colonize Mars, they would need to look for certain things. One of these things would be water. Underground aquifers would make a great source of water if they were drinkable for the people on Mars. This could be found with resistivity surveys. Another thing we would need to find would be resources. This would be much cheaper than shipping things from Earth. The Martian crust contains 4 to 5 times the iron content as the Earth's crust. With this much iron, it is likely there's higher resources of things like gold, silver, copper, and zinc. We'll be able to find these things using surveys such as magnetics and gravity. Finally, a habitat would be good to find, away from the dangers on the surface. It has been theorized that caves would make a good area for human habitation. This would be possible to find using things such as gravity surveys, resistivity, and GPR. There are many other tools for many other needs. Could I please get the next slide, Julie? Thank you. All these methods are valuable resources. However, it is important to understand the difficulties and problems that might arise with these surveys when on Mars. This is where analogs can highlight things. My project in Utah will be to do a magnetic survey. Since I cannot take magnetic equipment with me, I will have to make it. I'm using a Raspberry Pi with a magnetic sensor and connecting it to drones to do aerial surveys. Now, Mars does not have a current magnetic field. However, there's still remnant magnetism in the crust from when it did. This means it's possible to pick out magnetic units. I will be combining my magnetic surveys with things like geological surveys and aerial photography to make one big comprehensive map.
Yeah, thank you, Kelly. So we'd like to conclude our talk by thanking our partners and sponsors. So like the AIAA, who kindly offered us this platform to spread our word, and all the other sponsors that contributed financially, but also trust us with the research they would like to take at their MDRS station. And please reach out to us if you have any questions, inquiries, or if you'd like to share any ideas you'd have for a collaboration, or just to exchange on space exploration, or the role of women in space exploration. Here's our email address, our website, and if you're feeling generous, you can make a small donation on our crowdfunding campaign. Thank you very much for your attention.
Julie, before we open the session for all the people present today and the participants, so I just wanted to know I had some questions for you. So the MDRS facility has some selection criteria which you clearly won. So could you just explain us through that?
Yes, sure. So we were not given the precise selection criteria. So you could either apply as a formed crew, or you can apply as an individual, and they will then assign you to another crew. They examine each of the applications very carefully. So of course you have to be somehow related to space sciences. Usually they accept undergrad students, but they would prefer to have like postgraduate students as well, or even young professionals. But yeah, again, they didn't specify the precise selection criteria. So we just, yeah.
If I may add, one of the important criteria for a team, as Julie said, you can either apply as an individual or as a crew. One important criteria selection for the crew is to have a diverse panel of crew members. So, for example, I'm an engineer, Kelly's a geophysicist. You really need to have a diverse crew to be able to lead as many experiments possible once you're there.
And you also mentioned something about your independent research. Could you also tell us a bit more about that?
Yes, Of course. So as most of us are students or just young professionals, we usually conduct our research under the supervision of supervisors, academic supervisors, or within the company we work in. So here most of us actually, I design my research without any supervision. So I'm still hoping to incorporate it in my future PhD, but I still decided on how I wanted to conduct my research. So this is a great opportunity for us to gain experience and confidence in leading our own research. But then Paula, our crew biologist, will conduct a mental health study. And here we are in collaboration with Dr. Popovite from the University of Iowa. So here, this research will be pretty much the guinea pigs of the study. So we won't conduct this research independently. So there's different levels of independence we get in our research.
Yep, that's the questions from me. So if anyone has a question, could you just please click yes on your panel so that I can open the mic? I'll be opening the mic. I think they should be open for you to unmute yourself. So do we have any questions coming from the participants today?
We explained everything perfectly clearly, I imagine.
No, I'm just checking if, do we have questions from the audience?
Anyway, if no one has questions right now, please feel free to send us your question by email.
I think
when it comes up.
Yes, I've got a question. Case Bill here. I just want to know what's the future of the project after you leave the habitat? Is there a follow-up as a team, or is it just the activity in the habitat that you're working together on?
Lauren, do you want to answer
Sure.
that?
So for half of the crew actually wants to become eventually astronauts. We are very ambitious young women. So as one of the motivations that Julie presented at the beginning of the presentation, this is hopefully the first of many analog missions. Or the ultimate goal would be the Concordia station in Antarctica, owned by the European Space Agency. So eventually the goal after the mission is to pursue and to continue the work we've begun. Individually, for example, for Julie, who mentioned that her research will be linked hopefully to her PhD, and as a crew in hopefully future analog missions.
Just tack on to the end of that, they also encourage to publish papers if you get significant enough results. So depending on how the trip goes, that might also be an outcome.
We have next question. Anyone has any more questions from the audience?
Could I ask a question, please?
Yep, go ahead.
Awesome. Well, thank you very much, ladies, for the talk. It was very, very interesting. Probably a question more directed towards Julie. Have you ever sort of considered doing any type of research with the astrogeology here in Australia, or anything relating to meteorites in that same field?
So I have not with meteorites. So my master's research project was on hydrothermal deposits from New Zealand, and I would like to continue working on hydrothermal deposits for now, but I'm open to any astrobiology related studies. So I'm really committed to search for extraterrestrial life. So if a project comes up on meteorites, I would definitely be open to it. but I have a little bit of expertise now in hydrothermal deposits, so centers as they're called. So yeah, I keep my doors open.
Excellent. Yeah, thank you for that.
Thank you.
So if anyone has a question, please unmute yourself. I think the mics are open to unmute. So I just had a question till and someone pops up. Julia and the crew said there was a research going on with the with your mental health. So does it apply to the COVID-19 situation or the situation that might come next?
Yes, thank you for your question. So Dr. Popovite has been working with the MDRS for a few years now. So our study will be part of a long-term monitoring research. So I'm guessing that the COVID-19 situation will be a factor that we need to take into account, but it's not the main focus of the study.
I understand that, but is there a similarity between the isolation that the astronauts or the crew would experience in such long periods and compared to what we recently saw as well?
Yeah, so definitely, I mean, we've all been at some point in isolation or confinement, more or less restricted. For example, I spent the past 6 months completely isolated in Australia, like thousands of kilometers far from home. So there are definitely similarities where we've been used to go out and interact we took that for granted, and suddenly we got like confined in our homes. So and we didn't get any training for that. Astronauts get trained for years, and so there are definitely similarities between the two situations. I don't know if yeah.
Yeah, it's important to note also that even if there are similarities, I don't think you can fully compare it to astronauts' isolation in the sense that we are in the comfort of our own home. We have our bed, we have our fresh food. We are just a phone call away from friends. You don't have any communication delays between you and your friends. So it's also, it is a good introduction to isolation. It does not fully reflect the difficulties of full astronauts isolation.
Yep. Is there anyone from the audience who would like to ask any more questions on their research project? No? Yes, no? I think so. It's a no. So Lauren, as a bit of curiosity, you did mention in your previous in your slide that the Apollo mission went on more to around 36 kilometers, whereas the Curiosity rover went on 22 kilometers. Could you guide us through a bit more on that and the statistics sort of behind that, and how it would affect your mission? So if you were to choose a rover, what would be your best bet going ahead?
Well, one of the most obvious reasons for this difference in kilometers is that once you finally manage to put your rovers on Mars, the last thing you want to do is just sprint out on the wild and go ahead and just crash on a rock 5 minutes later, because you spend so much time and so much money on getting that rover working on Mars that you are being extremely careful to your environment, to every single obstacle, to every hole, every rock, everything is determined. And it takes a while to create the navigation path of the rover. You know, when you're an astronaut, you finally made it to the moon or to Mars. And so you have a better visual of what's happening, of the surrounding, of the environment. So therefore, you can take more liberties than if you were on a rover. Especially one of the point is if you have an issue with a lunar roving vehicle, a Martian future roving vehicle, you can try to fix it as an astronaut. You know, astronauts are trained to fix those rovers. Whereas if you have a technical issue on your Martian rovers without anyone here to help, yeah, it's more complicated, you know. So you take more liberties once you have an astronaut here to help and to fix and to visualize your environment. As for how it will affect our mission on the MDRS, as Julie mentioned, we are lucky to have small rovers accessible to us on the MDRS. So I imagine I'll see firsthand the way I'll have to program the navigation path of the rover, and I'll be able to compare it to not a car ride per se, but a Martian roving vehicle's trajectory. So yeah, this will definitely be an interesting point to bring up.
Thank you. Do we have any other questions from the audience? Okay, so I think I'm the most curious guy here. I have one more question for Kelly, who mentioned about the Raspberry Pi use on the drone. So could you tell us more about what other sort of available tools you would have at your disposal when you're at the MDRS to simulate the scenario as well?
So I wouldn't be using any tools at MDRS. I would be bringing, well, we'd be bringing most of them. So the drone, as we said, was being, we're using from Drononomy, which doesn't use a GPS. So I'd be using that and attaching, the Raspberry Pi is effectively like a tiny computer. So it's just there to collect the data. And so I can dump it onto a computer later and then work out the filtering and the mapping and the stuff afterwards. So those would be my main project.
And could you help us navigate more through the, how would you navigate the drone without a GPS, that part a bit?
So that's actually the company that has developed this drone. So I don't actually know much about this. This was someone reached out to us to tell us, ask us to test this. So I'd be interested myself.
And you also mentioned about the magnetic field being low. Is that one of the ways that you can overcome?
Well, it's actually better for if you're detecting magnetic anomalies. The biggest problem with Earth is we have such a strong magnetic field that you're measuring very, very small changes in this magnetic susceptibility. But on Mars, there is no magnetic field anymore. So therefore, anything giving off a magnetic field will be very obvious because there's no background noise to convolute it.
Yep. Okay.
So you can take instruments that are less sensitive. So I think they had one on the satellite that they've been using currently. But if you could get ground surveys, you get a lot more finer details.
Definitely. I think that's all the questions from me. I think anyone else from the audience? No? Okay, we don't have any more questions from the audience. So we will keep the, I think your email address is out, and we will send it to the attendees today who have attended of what the presentation was. And if they have any questions on your MDRS queue. So yeah, that's all from the AIAA Sydney section for today. But we do have, for all our participants, we do have a few more events lined up within the coming months, and stay tuned for such projects. And we would like to thank Kelly, Lauren, and Julie who took their time out. And I think Lauren and Julie, Kelly is based in Australia at the moment, but Lauren and Julie are both in the European time zone.
Yes, we are. But it's fine, it's 10:44 here, so we're in the middle of the day. But thank you so much, Nimish, for giving us a platform to share our project. And of course, yes, feel free to drop us an email if you have any questions or just to talk about space exploration in general.
Not a problem. Thank you. Thanks, guys.
Thank you.
Thank you.
Thank you, Mr. Tavares.
Thank you. Very good talk.
Thank you very much to all of you.